Okay, let me switch to the work package 3. The work package 3 is focused on scalable solvers. This is the work package in which linear algebra solvers are at work. Let me remind you the main objective of this technical work package. Our main objective is to prepare the flagship codes in order to be run on near future exascale platforms. So taking into account that one of the main kernels of all the flagships of most all the flagships code is a linear algebra problem. In this work package we work on exascale enabled linear algebra kernels. Essentially, we focus on sparse linear systems and dense linear systems on exascale machine. Let me remind you that we have many linear algebra players coming from Surfax, CNR, CNRS, INRIA, ULP, and University of Rome Tor Vergata. And then we play in this work package together with people coming from scientific challenges context in order to be able to integrate our solvers into the application codes. So, activities in this work package are essentially organized in different tasks, as in the other work package. But on the other side, we have 3 main lines that are general, on which we are working on. We are working in interfacing general purpose already available packages into the application codes. On the other hand, we also have some efforts in the extension or improvement of already available solvers in terms of robustness and essentially scalability in order to meet specific requests from the application side. And last but not least, in some cases, for example, in the fusion scientific challenge case, we are working on application-specific solver related to the specific request coming from the context. So let me say that considering the different scientific challenges in which we planned to work, we have materials in which the activities are not yet started. We planned not a big effort in this context. We planned to interface Chameleon package to PV-NeGF, but for problem related to some delay in recruitment of postdoc, we didn't start yet this activity. In the case of water and fusion, we can say that we just started on the staff, and I am talking about our achievement for this first phase of the project in this context. So in the wind, we can say that the activities are in progress in the sense that maybe this is the only context in which we already integrated some of our libraries into the ALIA code, that is the flagship code for this scientific challenge. And so we can say that in these scientific challenges, we are ready to go ahead in order to get some scalability analysis inside realistic simulation. Okay, let me focus on the state of the art, a snapshot of the activities. Concerning the water scientific challenge, we have different subtasks. In the case of the first subtask, we focus on the improvement of PS Blast and Hamlet 22P4 libraries for running on GPUs in order to solve one of the main kernel of parflow code, that is a Poisson type solvers characterized by some levels of anisotropy. In the first phase of the project, we focused on the design development of some smoothers and coarser level solvers that are able to work enough well on GPU. And we obtained some results testing these functionalities of our GPU plugins on PitsDint by using a Praise infrastructure and account coming from the project. And our test cases came from a mini app for groundwater modeling in the case of isotropy, written by Jülich and translated by us in our framework. We obtained good scalability by using until up to 512 GPUs on PitsDint, and we are able to say that our platform is good in terms of implementation scalability, but has to be improved in terms of algorithmic aspect, since we see that growing up with the GPU's number, we lost something in terms of numerical scalability for related to the choice of the smoother and the coarsest solvers that are specifically tuned for GPU. In this context, we also have another line of activities in which we have to interface our platform directly to parflow in order to do simulation inside the code on realistic test cases. And we can say now that we are ready for starting activities, since in CNR and in Jülich group, we just hired two young scientists to start these activities. And today we also planned some specific activity with the Stefan group. The other subtask related to water is related to the interface of AGMG, that is one of our algebraic multigrid solver. The problem here is to have a new scientist for technical work on these activities. Indeed, the activities have not yet started, and presumably we have a young scientist for this next month. For the scientific challenge related to fusion, we have a task coordinated by Holy Rudy in Cefax. And in this task, main activities were started and focused on the development of multi-grid solvers, of geometric multi-grid solver, specifically written for the gyrokinetic Poisson equation, that is main kernel in the code. And the problem here is related to the use of polar coordinates that are good in the case of the type of geometry we are considering. And the group of Huli, in particular there is Martin we have here, is working on a specific geometric multigrid in which they use a line smoother depending on the direction, in particular depending on the circular or radial direction, and they combine results in extrapolation approach by using function basis implicitly defined design in the multi-grid. They obtain interesting results in terms of convergence, and they have to continue in order to get a parallel implementation of this algorithm and this solver to be integrated in GIS-LIX. Some other activities on the fusion are planned in our work plane, and these activities are related to the integration of AGMG into TOCAM 3X. Ivan worked on this aspect in collaboration with SEHA, and they collaborate in order to obtain a reformulation of the discretization scheme in order to modify the matrix data and to reveal the symmetry of the system matrix in order to avoid some glue code that was written in the first phase of the project, making AGMG more efficient to do the solver phase. In this subtask, work is ongoing, and some testing and tuning have to be done. There are some other fusion, some other activities concerning the fusion work plane, and the planned contribution come from CNRS ERIT, further denser fax, in RIA and MPG, and we are waiting for hiring young collaborators and scientists in order to start these activities. All of these activities are essentially related to the experimentation of the other linear algebra solver available in this project for the Laplace type equation of this type of problems. We also have some activities on the wind scientific challenge. And the main objective here is to have a good solver for pressure equation coming in RANS model or LESS model in the fluid dynamic part of the ALIA code. In this case, we have some activity at CNR in which we focused on design and development of a new parallel aggregation scheme to improve scalability, numerical scalability, but also implementation scalability in our algebraic multigrid methods implemented in the framework. And we did some tests on some standard test cases on Mare Nostrum 4 with the account available from Brace, and we have some very promising results, both in terms of scalability up to more than 4,000 cores, and in terms of comparison with other available solvers such as preconditioner based on algebraic multigrid methods available in HyPre. Let me say that these activities were also the main subject of two invited presentations to two different international conferences this year. We have also to do some other work on the ALIA code. We have to interface our solver to the code. In this case, we are in a good situation since both the iterative solvers, but also some other solvers available in this project are already interfaced with the ALIA code. And at the moment, we only need to do testing and tuning in order to verify the real performance of the solvers on ALIA in realistic simulation. Last but not least, we also have some efforts on transversal activities. In this context, at the moment, we can put some efforts that were done essentially on a voluntary based by Ivan and Salvatore Filippone in order to define a possible template for a common interface to all the libraries that are available in the project. Main interest is to have a possible unique entry point to all the libraries. But of course, we don't have the same features in terms of solvers coming from all the libraries already available, and the discussion is already ongoing. This morning we had a working session, and we are thinking to put the document that we discussed on the first deliverable as a basis for possible future activities, but not to be considered or implemented in this project. Okay, as I already said, in this meeting, we organized 2 different working sessions. One working session was held this morning. The second one is related to our delay in writing the deliverable that was due by the end of August. Tomorrow, we have a working session to define in details the content of the deliverable and to propose a new deadline to the Commission. We have already contributed to the first newsletter of the project, and we need to contribute to the next newsletter and to the webinars for 2020. Then in this meeting we decide all these contribution, and people are working on that, and we will fix the date for a workshop to be held in Naples for next year. Okay, let's hope for a great job, and thank you for your attention.